Hello everyone. The topic to be discussed now is assignment problem in operations research. Assignment is usually a method of allocating the task, jobs, facilities or equipments to workers, processes, locations and resources. Every organization in their production process try to find out an optimal solution in the allocation to minimize the cost. So there are two objectives in the organizations. One is to maximize the profit, the other one is to minimize the cost. So with this minimization of cost, all possible measures and allocations will be done to reduce the cost in all feasible way. So a process that could help in allocation of the task to the machines to minimize the cost is called assignment, and this process is usually adopted under the Hungarian method of allocation, which is a popular method in the quantitative techniques methodologies. And this system is usually adopted with a procedure or sum of calculations with the given information regarding the cost of allocating jobs to the machines. So assignment is simply considered as allocating jobs to persons or machines, and with the optimization of the cost with the aim of reducing the cost, and that feasible solution is identified by following certain methodologies. So this is a problem that is given with the cost elements fixed with the jobs and missions. It indicates like what cost will be involved in allocating the jobs to the mission. The given matrix is a 4x5 matrix with values representing the cost of each job allocated to the mission. If the first job is allocated to the first mission, the cost is 10 rupees. If the first job is allocated to the second mission, the cost would be 11. And the same is allocated to the third mission, the cost will be 4. So here the matrix given is 4x5 matrix. That is, there are 4 jobs and 5 missions. And this solution to be found out by balancing the matrix. The balanced matrix can be adopted by equating the number of rows with number of columns. So the given problem is an unbalanced problem, and to arrive at the solution, we have to balance the given matrix. To balance a given matrix, the rows that is uneven with the columns has to be matched with the number of columns. Say for example, here there are 4 rows and 5 columns. So we have to match the number of rows to the columns by adding 0 elements at the bottom of the row. So when zeros are added at the bottom of the row, the balance matrix is arrived at by equating the number of rows with the number of columns. So the adding dummy rows is the basic element or the basic function to be adopted in case of any unbalanced matrix given for the problem. So balancing the equation is all the similar way in which the matrix is also balanced. So number of rows and number of columns are identified as the first step that should be equal in number. So this is the first prior activity that should be done in case of moving with the solution of finding out the assignment using Hungarian method. So the identified matrix 5x5 matrix is converted into a simplified or a reduced matrix by adopting the technique of row reduction. So here row reduction is a concept where each least element in every row is identified, and every element of that particular least cost element is deducted from the every element of the row. Here we have 10, 11, 4, 2, 8 in the first row, and the least cost element is 2. By taking 2 as the least cost element, this is considered as the key element for the first row. We are deducting this 2 from each element, like 10 minus 2, 11 minus 2, 4 minus 2, 2 minus 2, and 8 minus 2. This will give us a new row value like 8, 9, 2, 0, and 6. Similarly, in the second row, the least cost element is 7. So we deduct 7 from each element of the matrix. 7 minus 7, 11 minus 7, 10 minus 7, 14 minus 7, and 12 minus 7. So this is the second row value. Deriving of the third row, we are identifying the least cost element as 5. 5 minus 5, 6 minus 5, 9 minus 5, 12 minus 5, and 14 minus 5. So this will give the new values of the third row. So similarly, we proceed with the fourth row and the fifth row. With all these values, new values derived at, we form a new matrix, that is row reduced matrix. With the row reduction, we proceed with the column reduction also. For column reduction, we identify the least cost element for each column, and that particular element is deducted from each element of that particular column. Say for example here, in the first column, we have 0 as the least cost element, which is deducted from each element of that particular column, like 8 minus 0, 0 minus 0, 0 minus 0, 6 minus 0, 0 minus 0. So anything minus subtracted as 0 will give the same value. So we get the same matrix, like row reduced matrix is equal to column reduced matrix. This will not give an effect in the new matrix, since we have added zeros in all the columns. And if at all these zeros are not added, we'll get a new matrix identifying the least cost element in each column. So here we don't have the effect of column reduction in the new matrix. So after proceeding with the row reduction and the column reduction, we try to assign the elements assign the jobs to the machines. The first row has 1 0. So assignment is usually done with the zeros. So wherever we find a 0, that particular element is assigned to that particular job. Here we have 0 as the first element in the first row in the fourth column. So that particular job is assigned to that particular machine in the fourth column. So once you have assigned that particular 0, we can strike out all the remaining zeros in that particular column in which the assignment is made. So we proceed with the row, identifying each zero in each row and assigning that to that particular column. So when the first assignment is made, we'll go with the second row. Second row, we have 0 in the first column. So we assign that in the first column and strike out the remaining zeros in the next simultaneous rows. So first row is over. Second row allocation is also over. Once the allocation for the second row is over, the zeros in the column, same column, it has been assigned in the first column. So zeros in the first column has been striked out. So we go with the third allocation. Third row allocation does not have any zero because whatever that is already present as zero is being striked out. So we go with the fourth row. In the fourth row, at the end, we have a zero. In the fifth column, the zero is being assigned to the fifth column, and simultaneous zeros in the same column, fifth column, is being striked out. And coming to the last row, we find a 0 in the second column. So the allocation is made to the second column. So since the allocation is made, we strike out all the remaining zeros left after that particular column. But since we don't have any column, we allocate that 0 and we identify if any allocation is not made. Here the left out is in the third row. Third row, there is no allocation. So what we do is we try to find out column by zeros. No zeros are found in any column. So we proceed with the null allocation as non-optimal solution for the problem, and there is one more step to be adopted to make this as an optimum solution, to arrive at the optimum solution. The next step is striking out all the zeros with minimal possible lines. These lines can be drawn either horizontally or vertically, matching up or marking up all the zeros, striking out all the zeros in the matrix. So here we can take up 4 minimum lines that could join all the zeros, which is drawn both parallelly and horizontally. And the left out region, which is unmarked, has to be adjusted, and also the points where these lines intersect, that has also to be adjusted. So with that adjustment, we'll come out with a new matrix. Here, the non-striked region have values like 4, 3, 7, 5, 1, 4, 7, 9. And the least cost element in the non-striked region is 1, which is taken as a key element to mark the changes in the new matrix. 1 is taken as the new value, and this 1 has to be adjusted with the intersect value like 8, 6, and 0. 8 has to be adjusted with 1 by increasing the value to 9. So 8 plus 1 is 9, 6 plus 1 is 7, and 0 plus 1 is 1. So this is how we'll adjust the values for the intersecting points. and the point that is unmarked 43751479 has to be adjusted by reducing the value of 1 from each element. So 4 minus 1, 3 minus 1, 7 minus 1, 5 minus 1, 1 minus 1, 4 minus 1, 7 minus 1, and 9 minus 1. So this will give you the new values. Similarly, the marked areas, marked regions in the lines will not be taken into consideration, then those values can be left as such. So only two adjustments are made. The left out region, the non-striked values are identified, and out of that, the least value is taken up, and with that least value, we have to add up least value at the intersecting points, and the unadjusted values, the non-striked areas have to be reduced with the least value, and the striked areas can be left as such. So these two adjustments are made to arrive at the new matrix. So we get the new matrix as 99206 03264 003687843010000. So here we can find out the intersecting point 8 is being increased to 9, 8 plus 1, 9, 6 plus 1, 7, and 0 plus 1, 1. And those are unmarked regions. 4 is reduced to 3, 4 minus 1, 3, 3 minus 1, 2, and 7 minus 1, 6, and 5 minus 1, 4. And for 1 minus 1, 0, 4 minus 1, 3, 7 minus 1, 6, and 9 minus 1, 8. So other values will remain as such. This is a new formed matrix, and now we try to make some allocations. We go with the first row, we find a 0 there in the fourth column, which will be allocated to the fourth column, and any zeros in the fourth column will be striked out. We have a 0 in the last row, so which is being striked out. In the second row, we find a 0 in the first column, which is being allocated, and the remaining zeros in the same column has been striked out. And similarly, in the third row, we try to make an allocation. In the second column, we have a 0 that has been marked, and the remaining zeros in that particular second column is striked out. And in the fourth row, we have a 0 in the last column, which is also considered, and the remaining zeros are being made. And the fifth column also, we have a remaining 0 that is also allocated. So with this modification, we can find out all the jobs can be allocated to all the machines. So there is an optimum allocation solution found out. So with this, we find out the structure, like job 1 is allocated to job machine 4, job 2 is allocated to machine 1, job 3 is allocated to machine 2, job 4 is allocated to machine 5, and whereas machine 3 does not have any allocation, because when the allocation is made to machine 3, it will involve more cost, and moreover there were only 4 jobs which could be allocated to 5 machines, so one machine has to go without any allocation. So machine 3 has no allocation, assignment or allocation. So optimal time for setting up here comes to 2 plus 7 plus 6 plus 7 hours. So totally 22 hours is the total account that has been taken into consideration. So with this, we come to the end of the assignment problem, and hope the video was useful to you. Thank you.